Okay. Now, I want you to think about that for a moment. What is sine? Y over R, or opposite over hypotenuse. Now wait a minute, you guys, I just want you to process this for a second. Think about a triangle. If opposite over hypotenuse has to be 1, doesn't that mean they're the same? Can that be? Can you have a triangle where a leg, a right triangle I should say, a right triangle, where a leg and the hypotenuse match?
No.
No, why not, Jimmy?
Because the hypotenuse is
It's always bigger. Yeah, it's always bigger. So what you're telling me is that situation is not possible to depict with a triangle. Can't do it. Okay, wait a minute, we've run into that before. If you can't use a triangle, then you have to use a circle. So let's look at our circle. And the radius, we're going to arbitrarily let be 1. So if the radius of this circle is 1, tell me about these points. What are the coordinates of this point if the radius is 1? 1, 0. And this one is 0, 1. Negative 1, 0, and 0, negative 1. Now, put the pieces together. When could we not draw a triangle in our earlier work? We couldn't draw a triangle if the angle was on the 180, 90, right, on an axis. So if I can't draw a triangle, then my angle is on an axis. It's one of those. Okay? So now just go around and figure out where is y over r equal to 1. Now r is 1 automatically. So don't we need y to be 1? Where does that happen? Where is the y coordinate 1? 90. So the answer to the problem is 90 degrees. And in radians, that's 90 degrees. How many radians is 90? I think I heard someone say, not 2.
1/2.
Pi over 2. 1/2 pi? Because pi is 180. So is it 90 half of that? Now that's the last one of those. I want to do another one, just to make sure we're back in the groove here. And then I got a little review for us to do. But let's try this. Let's find cosine equals negative root 3 over 2. So Eli says that cosine is negative. And cosine is associated with x, right? And if it has to be negative, then doesn't it have to be over here? So my butterfly bow tie, I've got a triangle here and a triangle here. Because those are the triangles that have a negative x. Are you with me? Okay, let's label it. So this is negative root 3, and this is 2. Does that look okay? That should look familiar to you. Isn't this a 1? And been the same down here in this one, only it would be -1 down there. But remember, when you do multiple triangles in the same problem, they're the same. Now, here's the key. This angle right here. The angle formed right here. How big is that angle? It's across from the 1. So it is 30. The answer to the problem is not 30. The answer to the problem is my pink angle. Can you figure out how big that is?
150.
150. And my blue angle, now remember, this is also 30. So my blue angle would be 210.
Boy.
180 plus 30, 210. Do you remember that from yesterday? Doing those things? All right, let's do one more that I don't, I need a circle for. How about if we want the cosine to be 0? Now, the reason I know I have a circle is because this would tell me that I would have to have something like this. Adjacent over hypotenuse would have to be 0, and I can't have a triangle with a 0. So does it make sense to you that I'll be using a circle?
Yeah.
So here I go around my circle again. This is 1, 0, 0, 1, -1, 0, 0, -1. I'm automatically making my radius 1. Has nothing to do with the answer, but it makes my job a lot easier. What's cosine? X over R? I know R is 1, that never changes. So I guess I need X to be 0? Well, where does that happen? Around the circle, where is X 0? 90 and 270. This one has 2 answers, 90 and 270. I haven't been answering in radians, so tell me. I already know from the last problem, this is pi over 2. What's 270? 3 pi over 2? Again, if you're a little confused by that, remember this is 0 and this is 180. So this is pi. This is half of pi because it's halfway. And then this would be pi and another half. So 1 1/2, which is 3/2. Now, let's change these to radians. Pi is 180. What's 30 then? If pi is 180, what's 30? Pi over 6? 1/6? What's going on here? Use a different color. So this angle right here is pi over 6. So you know how you found 150? Didn't you take 180 minus 30? Well, in radians, what would I do? Pi minus a 6th? That's a 6th. So 180 minus 30, or pi minus a 6th. What's 1 minus 1/6? 5/6. So 150 is 5 pi over 6. It's a whole pi minus a 6th. What would 210 be? It's a whole pi plus a 6th. 7 pi over 6. Beautiful. Beautiful, beautiful. Okay? All right, let's do a little bit of review here. Our next section is graphing, so it's completely different. Not completely, but it is significantly So we're going to do a little review. So here's the plan for those of you that plan. Tomorrow, your class tomorrow. No. So Friday, we'll get our other quizzes back and review. And then the class after that, we'll have another quiz. Okay? So schedule your life. Okay, the page, this is a big review packet. The page I want to look at is page 2. It says Christmas gift worksheet. Back in the old days when we had class every day, and we actually had class, we had finished all this before Christmas. So this was their Christmas review. But here we go, let's get part of it done. We're not gonna do the whole thing today, we're gonna do part of it today. So let's get our calculators out. Convert to DMS. Who remembers how to do that? Convert to DMS. First, we have to type in our number, right? So first we'll type 38.21. Right? And then the second apps, second angle, click down on DMS, and what does it say? What's your answer?
38, 12, 36.
Thank you. 38 degrees, 12 minutes, and 36 seconds. And that is exactly how we write our answer, and that is all there is to it. Okay? All right, now what about the next one? The next one is backwards of that. So what do we do there? All right, how do we do our next one?
Go in and just type in.
Type in the first number, so it is 52, and then second apps degrees, and then 11, second apps minutes, and then the tricky part, 8 alpha plus 52.186. Everybody good with that? All right, number 2, find the arc length. When I say the word arc length, what pops into your head?
Radius of radius.
Very good. Radius times radians. All right, what have I got? I've got a radius that's 6, but my angle is 100 degrees. That won't work. What do I have to do? Change it into radians. So one way to do that is pi is to 180, is something is to 100. If you have another way of doing that conversion, it's fine. Just make sure it's right. Don't be making stuff up. What about 100 over 180? That will reduce to what? 5 over 9, 5 pi over 9. So that's what I'm going to put right here, 5 pi over 9. That's my radian measure. And then I'm going to multiply. So I have 30 pi over 9, which reduces itself to 10 pi over 3. And since my radius is feet, this should be feet. The arc length it's gonna be inches or meters or something like that. Royce, you all right?
Yeah.
Okay. All right, number 3, what do you think?
Wait, so what was the answer for that? That's the answer for that one.
Yeah. Radius times radians. All right. Where do I even begin with problem 3?
Also,
8 miles in 1 hour? And I'm gonna do a whole bunch of stuff here. And what do I eventually need to end up with?
Revolutions per minute.
Revolutions per minute. So eventually I'm gonna get to revolutions per minute. Now, getting from hours to minutes is never a problem for anybody, because we all know that 1 hour is 60 minutes, right?
yeah.
Okay, done. That's easy. The hard part, it's not hard, but we forget how to get from miles to revolutions. So, does anybody remember the key to this? We talked about it back when we did it. What?
You have to do this.
Yes, Alden. A revolution is a circumference. So I need revolutions to be on the top. So I'm gonna say 1 revolution is a circumference. How do I find circumference? 2 pi r. What's my r? 12. So isn't this 24 pi inches? So 1 revolution is 24 pi inches. Now I gotta get these miles and inches to cancel out. So what do I know? Well, let's go 1 step at a time. 12 inches, 1 foot.
So 5280.
5,280 feet, 1 mile. And I think we got it. So hours are gone, miles are gone, feet are gone, inches are gone, and we are left with revolutions per minute. Now let's all type this in, because there's a little bit of a pitfall in there if you're not careful. So we have 8 times 12 times 5,280 on the top. And then I'm gonna divide by 60. I'm gonna divide either by 24 and then by pi, or put parentheses around that, because you have to divide by both of them. So divided by 2 pi in parentheses, and that's it.
24 pi.
Oh crap, thank you.
You're,
Did you get 112.045?
Yeah.
yeah.
So 112.045 revolutions per minute. So the key is, when you're simplifying this with your calculator, everything in the bottom gets divided individually. So you're dividing by 60, you're dividing by 24, you're dividing by pi. Everything in the bottom is divided, no times, no times. If it's in the bottom, it's getting divided. Anybody have a question about that one? Okay, number 4. Q is in quadrant 3. So I'm going to draw a triangle in quadrant 3. And I know that its tangent is 3/5. Now remember, this is always the angle in question, never the origin. What is tangent? Tangent is opposite over adjacent, TOA. So 3/5. Now there's something slightly wrong with that picture. Anybody see what it is? They both were negative. This is 4, there's no negative in the problem. No, there's not, because it canceled out. But these are both negative, would you agree? All right, what's the other thing I need to do next now? Find my hypotenuse. So what will that be?
5 squared.
5 squared plus 3 squared. So square root of 34. And now I gotta find everything. So I have to find sine, cosine, tangent I know. Cosecant, secant. So, even if you don't have any idea what to do, if you know the tangent is 3/5, you automatically know the cotangent is 5/3, because they're reciprocals, right? But if you do know what you're doing, and you've drawn this lovely picture, then you can look at it and say, okay, what is your sine? Opposite over hypotenuse? Remember, here's the angle, so this is the opposite side. So -3 over root 34. And your cosine is -5 over root 34. And these are the reciprocals. When you write a fraction, remember the negative can go anywhere. So your negative can be on the top or the bottom or right in the middle. I don't suggest that. Probably better to put either on the top or the bottom. Does anyone have a question about that? All right, just a couple more and then we'll do some new stuff. But let's get a couple more. Find the cosine of 11 pi over 6. What do you think? We're not just gonna type it in on our calculator, although you might need a baby calculator to help you do something. What might we do to start?
11 times 90.
Yeah, figure out how many degrees we've got. So it wouldn't be 11 times 90, it'd be 11 times 30. Because pi is 180, divided by 6 is 30. So we got that. So I think that's 330. You with me? If you're not, it's up to you. Get that hand up or say something. Okay, yep.
Is that because it's like, numerators? That you would multiply it instead of just dividing? 180 like if there was no 11, you just do 180 divided by
6, yep.
But because there's the 11, you have to.
Multiply by 11, yeah. So it's basically 11 times 180 divided by 6.
Okay.
If I'm not using a calculator, it's easier for me to divide first.
Yeah.
But if you're using a calculator, it doesn't matter. Okay. All right, what next? Well, where's 330?
It's gonna be bottom right.
As we go around the circle, I heard somebody say bottom right.
Yeah.
330 is right here. We call that quadrant 4. Let's make a triangle. butterfly bow tie. Pay attention, this is the angle we want right here. So if that's 330 and that's 360, then what's this? 30? And if that's 30, then what's this? Since I am not in quadrant 1, there has to be a negative somewhere. What is negative? The 1 is negative. The 2 will never be negative. The hypotenuse is never negative. That's right and down, so that's negative. All right, what's the cosine? Definition, adjacent over hypotenuse. So root 3 over 2? Right? Done with that one. All right. Tangent to pi. Tangent to pi. What's 2 pi? 360. Uh-oh. What's special about 360? It's right here, isn't it? Isn't it right here? Right here? And draw our circle. If the radius is 1, what are the coordinates of that point? 1, 0. Which means x is 1 and y is 0. What's tangent? Y over x. So y over x is 0 over 1, which is 0. Good? Do I have a brave soul who wants to come up and do the sine of 135? The sine of 135? Okay. Worst thing that can happen is you get it wrong. No big deal.
Yep.
Of course, you're on video.
What?
All right, let's step aside. Look what he did automatically. He popped it into quadrant 2, is he right? Yep, because 135 is bigger than 90 but less than 180. Perfect, keep going. He says his reference angle, that's what we call that little angle in there, is 45. Is he correct?
Yep.
The difference between 180 and 135 is perfect. Look how I labeled the sides, 1, 1, root 2. And he made this one, the x1, negative. Perfect. So now he's ready to write his answer. The sign is positive 1 over root 2. He did it. He did it. Did the rest of you do that? Does that make sense to you? That is absolutely beautiful. All right, last one, number 6. Last one we're going to do today. We're going to hang on to this sheet because we're going to do some more next time. But last one we're going to do today is secant or find the secant. So we've got this triangle. I didn't put a right angle there, but it's supposed to be a right angle. And we have to find the secant. Okay. So what is going through your head? Yep.
Gotta
right.
find hypotenuse over adjacent.
So secant is the reciprocal of the cosine, ka, so ka, toa. So cosine is adjacent over hypotenuse. So as he says, this is going to be hypotenuse over adjacent. Now this is your angle. So isn't this opposite and this adjacent right here?
Yeah.
So it's gonna be over 10. What do I need to do to find my hypotenuse? Pythagorean theorem. This is an easy one. It should be the square root of 149. How did we get 149? 100 plus 49, yeah. So that's all there is to it. Beautifully done. Beautifully done. So let's make a note. That's where we stop. And that's where we will pick up next time to do a little bit more review. Now we need to get our notes back out. And we're gonna start 4-4. For our quiz next week, 4-4 will not be on it. Alright, it's 4-1 to 4-3. There's a lot in 4-1 to 4-3, so we're gonna do quiz over that. Then we'll take a test over 4-1 to 4-5. So what we're quizzing over and then the graphs. Alright, so let's get this graphing on the books here. Here we go. If you, I think for you it's on the back. Yeah, if you look on the back of your green sheet, you have the curves all there for you. Those aren't just made up, those actually can be generated, and you actually have the capability of generating them. It's not that hard. But in the interest of time, we're just going to talk about the basic shapes of these, and we're just gonna know this is what a sign looks like. I'm gonna grab a white little sign X. This is what a sign looks like. A sign, remember your BFFs? Wasn't sine one of your BFFs? And so was cosine. What was the difference between those? Back in chapter 1 or whatever that was, what was the difference with the sine and the cosine? Do you remember?
One for the origin.
One of them went through the origin, and that was the sine. So the sine is a hill and a valley. And I'm gonna put arrows on both ends because technically it keeps on going forever and ever, because we can keep going around our circle forever and ever. But that is a sine curve. If I continued, I would have another hill and another valley. Does that make sense to you? And then another hill and another valley. What is special about 2 pi? It's once around the circle. If I go again around the circle, does it make sense? It would just repeat over and over and over again. That phenomenon where you have a chunk that repeats itself over and over again is called period. This function is periodic. It repeats. And the chunk that repeats is called the period, and it is 2 pi, once around the circle. You can go again if you want, but nothing's gonna change, and again and again and again. You're just gonna keep getting this hill and valley over and over and over again. That's called the period. This tells me that after I go once around, everything is gonna repeat. The height of the hills and valleys is 1, and that is referred to as amplitude. Remember when I said it was easier to make circles with a radius of 1? This is why. That 1 is the amplitude, and that is the height of the hill. That right there is the amplitude. And the height of the hill is the same as the depth of the valley. Amplitude amplitude is the height of the hill. So that's what you need to know about the sign. That's its shape. Notice these labels, what are those? You said 2 pi was all the way around, but what are these? Aren't these the axes? 90, 180, 270? All right, what about the cosine? What does it look like? It's exactly the same, except it starts up here. So it comes down and looks like this. Now, I'm gonna go ahead and dash this in. You don't need to do that, but can you see that the sine and the cosine are essentially the same curve? They just have a different starting point. But isn't their period the same? And their amplitude is the same. They are the same curve shifted. So I'm in my notes, 4.4, I've done the sine, I've done the cosine. Now, problem C, I'm gonna have to erase any room. Problem C says graph 2 sine. Are we okay with this? Everybody okay? All right. Now, who remembers what happens when we put a 2 in front of any function? What does that 2 do? Stretches it? Which way? Up and down or sideways?
Up and down.
Up and down. This is a vertical multiplier. A vertical multiplier. So what does that mean? That means it takes my sine curve but it multiplies the vertical by 2. So how high up did my sine curve go originally? 1. So now that's gonna get doubled. So now my sine curve is gonna go all the way up to 2. So the hill that goes from 0 to pi, that hill, now goes up to 2. What about the valley?
Goes down to 2.
Down to negative 2. Has my period changed? Nope, still going to 2 pi. But now my amplitude is 2. Because the amplitude is the height of the hill. And now the hill is 2. All right, let's look at these. We know what a cosine looks like. You've got it there on your paper. You graph the cosine. It's on your green sheet. What does multiplying it by negative 3 do?
Down.
It turns it upside down
Stretched.
and makes it 3 times as tall. So it turns it upside down. So remember, a normal cosine starts up here and goes like that. Isn't this one gonna start down here now? And go up? Cosines are sometimes hard to draw, but just like with sines, they're split up into 1, 2, 3, 4 little pieces. Alright, gonna have 4 labels. Those 4 labels are the quadrants. So it's pi over 2, pi, 3 pi over 2, and 2 pi. Remember that a cosine is going to start and end in the same place. With a regular cosine, it's up here. But an upside down one, it's gonna start and end in the same place. And if it helps you to continue it, go ahead. If that helps you see the waves, because I know it's a weird shape. What's the period?
2 pi.
Still 2 pi, we haven't changed that. What's the amplitude?
-3?
Actually, it's 3. Amplitude is the height of the hill. So even if the coefficient's negative, it's still going to be a positive number. Now, the negative is important. You can't forget the negative, because the negative turns you upside down. But as far as amplitude goes, it's always positive. Amplitude and period are both always positive. E. Just a couple more, hang in here, guys. Y equals 2 sine 2x. Tell me what you know. What do you know? Our amplitude is going to be 2. So whatever this sine thing looks like, it's going up to 2 and down to -2 because of this guy right here. That's a multiplier of the height. So would you agree that the shape will look something like this? And that's what sines look like. I got that down. Exactly. Very good. This guy right here, a coefficient on x is a divider. So this guy divides the width. This guy multiplies the height. Now that's not new to you. We studied all that way back when. But that's what happens. Those are the transformations. This is a divider. Now what does that mean? That means the original, and actually, sometimes I like to write them down. Here are the originals. Those are the original labels. What's happening to those? They're being divided by 2. So when I divide these by 2, oh, that's a fraction. Dividing by 2 is the same as multiplying by 1/2. So this will actually be pi over 4. And this will be pi over 2. What will this one be? 3 pi over 4. And what will this one be? We're dividing by 2. So it'll just be pi, won't it? 2 pi over 2. What's our amplitude? Amplitude is not 4. One more time, it's the height of the hill. How tall is the hill? 2. What is our period this time? Now our period's changed. Now our period is just pi.
It's where, oh, yeah.
Oh, no. Look at the next one.
We'll save that.
No. This will be our last problem, I promise.
No.
Oh, my
No.
goodness. I I can tell when I look at it that my amplitude.
Oh!
What is my amplitude going to be?
33.
What is my period going to be? Pi. Because it's 2 pi divided by 2. Remember, that's a divider.
Yup.
What the heck does that
Shift
do?
it.
Shifts it to the right. Very good, Alden. So, what does that mean? That means that instead of starting at the origin, which is where a sine curve should start, mine is starting at pi over 4. So I am going to draw a sine curve with an amplitude of 3, starting here. So there's my hill, there's my valley. Are you still with me so far?
So it doesn't go through at the end.
So now,
Ordered brain.
I've got my 4 sections, 1, 2, 3, 4. And I need to figure out what those labels are. Okay? Now remember, you already told me that the period was pi. You already told me that. What does that mean? That means from here to here is 1 pi. So if I start at 1/4, this is 1/4 pi, pi over 4. If I start at 1/4, and this is a whole pi, where would I end up? Not a pi.
5 pi over 4.
5 pi over 4. 5 pi over 4. Kids, if
Come
you
on now.
start at a 4th, start at a 4th, and you add 1, won't you be at 1 and a 4th?
Yeah.
Which is 5/4. Okay?
But isn't that the same as the one we just did? Like, we started at like 5 divided by 4, and then we ended with pi. So how is it different than?
It shifted. That one was started at 0. This one doesn't start at 0. Now, the increments are going to be the same size because that was a 2 and it was a 2 in the last problem. So the increments are all going to be the same size, but they're going to be in different places. Hey, are you guys paying attention? All right, we're almost done. We got to get all these labels done. See this one right here? It is going to be right in the middle of 1/4 and 5/4. Someone said it. 3/4. How do we know it's 3? Well, hopefully you could figure that out. But if you couldn't, you added and divided by 2. So what's 1 and 5? 6 divided by 2 is 3. That's how we find the midpoint. 1 and 3 is 4. Divided by 2 is 2/4. And 3 and 5 is 8. 4/4. 5. And you can reduce a couple of those, but you don't have to. But as Erica kind of was alluding to, these are all spaced evenly,
Yeah, they're all.
and they're all 1/4 apart.
So with the 4 pies over 4, would that be one around the circle?
No, this is one way, this is one surround the circle. And actually, it's not even one surround, because we're only going halfway around, because we changed our period.
Alright, back it up.
All right, we will continue our conversation next time.
You are. Where's the hat? How'd the hat look up there? Come on, bungalow.